This is video A23. Getting close to the end of things. Okay, so this is still section 13.1 where it's a geometry review. And now we're going to review special right triangles. And there were two that you studied. The first one was a 45, 45, 90 special right triangle. And we know that this would be an isosceles triangle since these base angles are congruent. We know that this is the hypotenuse, and so I'm going to use, I don't know why, but I always use little cursive letters for these. We call that the hypotenuse, little h, and then these are the two legs. And what you learned is that there is an extended ratio for the sides of any 45, 45, 90 right triangle. And I always like to write this vertically, and you'll see why when we do these problems. The ratio for this triangle goes leg to hypotenuse, as 1 is to the square root of 2. And all this means is that this ratio is 1 to 1. So if that's 5, that's 5. This ratio is 1 to the square root of 2. Okay, and we'll do an example with that in a little bit, but the other special right triangle was a 30, 60, 90 right triangle. So 30, 60, 90. And of course this again is the hypotenuse and these are the two legs, but now we remember that across from the smallest angle we have the shortest side of a triangle, and so I'm going to call this the short leg. Across from this is of course the biggest side. This would be the medium side, but it's the long leg. And you learned that there's an extended ratio for this as well. Short leg is to the long leg is to the hypotenuse, as 1 is to the square root of 3 is to 2. Okay, so the way in which we're going to use this, well, it's actually really involved later on, but for now, we're just going to remember how to solve special right triangles. So, example 1 today, if I gave you this triangle like this, and I say, okay, there that's a 90, and these are congruent, and this side is 8. If I say now find the other two sides right here, first thing you need to do is recognize that if these are congruent, they must be 45. So this is a 45, 45, 90. And then what I would always have my geometry kids do is write down this until they just knew it. Leg, leg, hypotenuse, 1, 1, square root 2. And the reason we do that, here I'll go ahead and label this x and this y, is because now in these columns I put these labels. So I'll start with the number. I know that 8 is the hypotenuse, so it goes in this column. And then these are both congruent legs, and it doesn't matter which I put where. And the reason I always have my geometry kids do that is because you have set up a proportion. Take the column with the numbers and then one of the variable columns and set them equal. And so I have a proportion. I can solve this for y, and I'll use the reciprocal property, where we can just flip over both sides of the proportion. And then I have to simplify this, so I'll multiply by the square root of 2 over itself. And I get 8 square root of 2 over 2, and then I reduce, and I get 4 times the square root of 2. And then we realize we didn't need to do that work. Okay, we could have just figured out if this is the square root of 2 times bigger, what must that be? Anyway, let's finish this. We could do the work again for x, but we'll get the same answer since the legs are congruent. And so I've now finished problem 1. Okay, problem 2. And let's say I give you this picture. That's x. This is 2x. Let's say that this is 3. This is y, and this is z, and I say find x, y, and z. Okay, well, we know that in a right triangle, these have to add up to 90. So we have 3x equals 90, and so x must be 30. So I'll label it there, making this a 30, 60, 90. So this is our 60-degree angle there. And once we realize that, we write down our extended ratio here. Short leg, long leg, hypotenuse, 1, square root of 3, 2. Start with your number. It's across from the 60, so it's the long leg. Okay, the z is across from the 30, so it's the short leg. And then the y, of course, is the hypotenuse. And all we have left to do is solve for z and y. So make a proportion out of the number column and one of the variable columns. Very similar work that we had down here. Okay, and so I'll use the reciprocal. I could cross multiply. It just adds a step, but go ahead and do that if that's what you like. But I get z equals 3 over the square root of 3. And then I multiply by that over itself. And simplify. Okay, now y, the hypotenuse, it better be bigger than 3. But I do the same thing. Here is my proportion now. Set them equal. Now I'll cross multiply. So I get y times the square root of 3 equals 3 times 2. Divide by the square root of 3. And then simplify the radical. The square root of 3 is about 1.7, and 2 times 1.7 is about 3.4, so it is the biggest side. Okay, but we're going to continue now because you guys have to do some word problems with these. I'll call this example 3. So a rocket is fired at an angle of 20 degrees with the ground, assuming a horizontal ground. And so here's my ground. Let's say the rocket starts there. It is fired at a 20-degree angle in that direction. Okay, and the question is, when it has traveled 2 miles, what is its elevation? So how high is it? So this would be the distance traveled here, so that's 2. Its elevation would be perpendicular to the ground, so we get a right triangle. And we have to ask ourselves, is this a special right triangle? And no, maybe a 20, 70, 90, and that's not special at all. So we'll have to resort to trig and our calculators. Okay, and so we want x, the elevation. Identify which trig ratio to use. So here's the acute angle we're dealing with. I have opposite hypotenuse, that's sine. So I write the sine of the acute angle is opposite over hypotenuse. And solving for x, I multiply by 2 on both sides. And that's the exact answer. But of course, we would never tell somebody that's how high it is. And so I want to remember how to enter this. If your calculator has gone into default mode, or if you've been doing later math, you'll be in radian mode. In this chapter, we learn what that means. But for this problem, we want to change to degree mode. So I hit mode, went down, hit degree. Okay, now hit enter. And then I just type in 2 times the sine of 20. And hopefully we get a reasonable answer. And so x is 0.684 miles. So the altitude, if you were writing the complete sentence, you would write after it travels for 2 miles, the altitude is 0.684 miles. Okay, and then just for later word problems, here's your eyeball looking straight ahead. There are your eyelashes, like that. You're looking in that direction. Okay, if they ever talk about an angle of elevation, you are going to go from looking straight ahead to something up. And so this angle through which your vision travels is called the angle of elevation. Okay, but let's say you have to look down at something. Something's down here. So you're going to depress the angle. And so this would be called the angle of depression. So now you should be able to do all of, I think, worksheet 13.1, oh my gosh, B. And you guys know where to find it.